Now, what we're going to look at is actually differentiating natural logs. It's not that difficult in terms of natural log, I would say, when you're differentiating.
No.
You must remember all the rules, all the differentiation rule applies. Alright? So today's lesson is talking about differentiating. Well, I need to show you differentiating of log x by first principle. Then we'll talk about differentiating y with log x using chain rule. And finally, apply the chain rule, quotient rule, and whatever it is to all the log functions so that we can differentiate them. Alright? Now, let's start off with this situation here. Let's look at the graph of fx equals log x. Natural log, not log 10, alright? So, if you look at the gradient function, think about the gradient function. Here, it's going from here all the way to, let's say, s. When x approaches infinity, what happened to the gradient function? What does it approach?
0.
0 because it approaches
Stationary point.
Okay. Alright, dy dx approaches 0. What about as its approach? X approaches 0. What happened to the gradient?
Infinity.
Infinity. So dy dx equals to infinity.
Oh, shit.
Now,
Actually,
so the focus
fine
question
with
for you now is think about that.
Something.
What
Wait, yes,
situation?
infinity.
So if I actually sketch this, the gradient function. So this is approaching infinity, this is approaching 0.
1 over
What
x.
do you think the function is?
1 over x.
1 over x. I think most of you know anyway. So you could actually guess the equation of the
1 over
gradient
x
function,
value x.
which is 1 over x. Yes, it is 1 over x, but how do we derive it? Alright? So now, let's look at it by first principle.
Yeah, mate.
So this is the one you should know from year 11 methods. First principle, limit of h approaching 0, function of x plus h, take away function of x divided by h. You should know that. Alright? So we know that fx now is log of x, natural log of x. So therefore, the first derivative of x, or f dash x, is limit h approach 0, log of x plus n, take away log x divided by h. Now,
It's not that hard.
what we need to do is,
Log law.
we need to, apply log laws.
X
What
plus
happened to the
h
log
over
laws?
x.
How do you do it? You know that therefore, that is x plus h divided by x. Alright? Don't bother about writing it down. You will get this, just concentrate. And take the 1 over h out. Alright? You know that now. Next thing we need to do is
Split it.
split it. So therefore, you know this is x divided by x, this is h divided by x. Alright? In maths, we can play around with pronumerals. Yeah? So I'm going to let n equals to h over x. So now instead of h over x, this is n. And therefore h here is nx. We do know that when h is approaching 0, n will approach 0 as well. Alright? So, substituting n equals to h over x back in here. We get first derivative of fx is limit n equals to 0 now, this time. As n approaches 0, h approaches 0, 1 over nx, log of 1 plus n. Alright? So now, let's split that again. 1 over n and 1 over nx, we split into 1 over x divided by n times 1 over n. Now you know that this limit applies to n. Doesn't affect 1 over x. So therefore, bring the x out. So we got limit of n approaching 0 and log 1 plus n. Agree? Yeah? Applying log laws again. So therefore, 1 over x equals to limit n approaches 0, log of 1 plus n to the power of 1 over n. Agree?
Yeah.
So what is that? What is that? 1 plus n. Let's take the log out. What is that limit? What number is that? E. Thank you, the Euler's number. So therefore, that equals to 1. So this is the proof. 1 over x times 1. The derivative of fx, first derivative of
Surely you
fx
never have to do that.
is
Yeah,
of equals log x is 1 over x.
There's a couple.
All right.
Why is the limit of that 8?
Hmm?
Why is the limit of that 8?
Go back to the first. Go back to first semester. Go back to first semester when I explained it. When we derived it.
Redo the course.
All right. Nah, that's okay. Just know that it is. I'm not going to explain it again. That it's explained in first semester. So I'm not going to explain.
You don't
why
need to
it's
know.
equal.
You don't need to know.
You just take it as face value. All right. All right. Just take it as face value. It is E. It will take me another half lesson to explain it. So. All right. So in your Waves formula sheet, you do have d dx log natural log of x equals 1 over x. Now, look at the domain and the
Yeah,
range.
that's right, that's right.
All right. So the range of fx is from negative infinity to positive infinity, right? Yeah, it goes on, although it approaches 0. It is not 0. Oh no, it doesn't approach 0, sorry. This one will go on infinity. It's not the gradient. So the red line will go to infinity. So the range is from minus infinity to positive infinity. So it's a whole range of real number. All right? What about domain of the function? Domain of the function is x greater than 0. All right? Here I've plotted the green line, which is the asymptote. Y-axis, x equals to 0. Now, then let's have a look at the range of the derivative. If it is 1 over x, and it is above 0. So therefore,
Yeah,
the range is from 0 to infinity. It has to be greater than 0. And the domain is actually the same, which is x greater than 0. You can see the asymptote there. All right? Yeah? Happy with that? I'll continue on. This is the one that you need to know. d dx log x equals to 1 over x. Now, the product rules, the quotient rule, and the chain rules all apply. All right? You must remember your product rule, your quotient rule, and the chain rule. It's in your formula sheet as well. So let's start with the first one. What do we do when y equals to log of natural log of x? We want the first derivative of that, dy dx of that.
3 on x.
3 over x, because we can,
Times. Just do times.
we don't have to worry about that. That's just a coefficient. Let's differentiate that. 3
You do 6
times 1 over x is 3 over x.
times that one.
Next one.
Can't do anything else.
Now, here, you've got an x to the power of 3. So it's a product.
Yep.
You need to use a product rule. So you need to differentiate.
-3 times 2, -6. 3 You put -2. That's it. That's what I was.
Yeah, which is x.
This
squared.
one first, times that.
Yeah, you can't. Yeah, you can't.
Then differentiate that times this. Correct?
Yep. And
Yep.
then you get x
So
squared.
the product rule, you must remember your product rule. And therefore you've got 3x ln x plus x squared. Oh, 3x squared. Yep, my fault.
Is that pasta speaking?
You know I do that sort of
Yeah.
mistakes. All right.
What'd you say, Juice?
3x squared. All right.
This
So
this
the next
pasta
one
kid, bro.
is actually
Come get away.
quotient law. All right, the rule, the quotient rule. So you got to
Yeah.
square the
So you could have
denominator.
done it all in one.
You can do it in as a whatever as well as a product rule if you want to use e to the power of minus 4x. But I just want to show you this is a quotient rule. That's all.
Yeah.
So therefore, you know that I'm going to square the denominator, and here 2 times 1 over x, because log x differentiate that e to the power 4x. Then you differentiate e to the power 4x is 4e to the power 4x times 2 log x. Right? Now, simplifying it. So therefore, you can take the x down. So which, if I take the x down, there should be an extra x there. All right? To make sure that it doesn't look untidy, to make sure that it's tidy, I will actually bring the x to the denominator. So it's 2e to the power 4x, because I've actually take this x out down as the denominator, so I need to include an extra x there. So if I multiply the x in, I can cancel out the x, and it's just 4 times 2 is 8x e to the power 4x log x. That's it. I mean, this is not wrong, but I just want to make it a little bit tidier. It looks better. That's it.
Actually, cancel out the
Right.
e to the 4x.
Sorry.
Can you cancel out e to the 4x? Common on both.
Yeah, you can.
You can take the e to the power, yeah, can if you want to, because you can take the e to the power 4x out, e to the power 4x divided by e to the power 8x. You can do that. All right. Next, differentiate with respect to x. This time, how are you going to do this?
Pull out the 5. You just rearrange.
What are you going to do?
Log laws.
General.
Log laws. Very good. So that's the first thing I do. Use log laws.
Anyway.
So there will be
should
5
just
log
change
x.
it.
Correct?
Huh?
There's no way you actually use chain.
Yeah. And therefore, dy dx is 5 over x. Try the next one, please. Use the log laws.
Same thing, eh? Same thing.
Yeah.
It is the same.
Use the log laws. Always use the
You
log
can
laws.
use change. Right?
All right. Now here, I split it out as log of 2 plus half of log x minus log of 7. I mean, you could have written down as log of 2 over 7 plus half of log x.
Yeah.
That's fine. So when you differentiate that, those are constant. You don't have to worry about it, correct?
Yeah.
Only think about this. So it's going to be half times 1 over x is 1 over 2x. So once you're familiar with how to differentiate, if you can't remember, this holiday go back and do a bit more. All right? I will give you some holiday work for revision. All right, next. Now, so here, example 3. Determine the equation of the tangent to the curve y equals to log x to the power of 3 and e and 3. So, what you need to do is start off by finding dy dx, correct? Yeah? So then you can find the gradient of the tangent. So rewrite this. Y equals log x to the power of 3 is 3 log x. Alright? So once you've done that, you can do your dy dx, which is 3 over x. Now, substitute x as e. So dy dx, when x equals to e, is 3 over x. That's your gradient, correct? Agree?
Yeah.
All agree? So if you agree, you can just write down y equals to 3 over x plus c. mx plus c. Now, tangent is a straight line.
There's
You
no
know-
C.
You know the gradient. You can just write y equals to mx plus c. I mean, you could do it that way, or you could use y minus y1 equals to m x minus x1, if you like. It's up to you. Really doesn't matter. So substitute that. You got 3 equals to 3 over e times e plus c. And therefore, you can see that c equals to 0. And the equation is y equals to 3x over e. That's all. Just remember, e is just a number. Nothing special about e. It's just a number. Alright? If you look at e is just a number. It's just a irrational number, that's all. Alright, example, next example. Alright, differentiate that. How are you going to differentiate this?
C equals 0.
Bro.
Alright, how are you going to differentiate
Why are
y
you
equals the
behind?
log of 3x squared plus 5x? Chain rule, thank you. How do you define?
F dash x on f of x.
Not yet.
What?
Let's think about this first. Alright? Let's think about using the chain rule first.
Just wait.
Alright? Now, so, using the chain rule, ignore this bit first.
I got it
It
right.
shouldn't be out first. Ignore this bit first.
You
Alright?
sub.
So,
Yeah, true.
if
Why would
you use the chain rule, dy dx equals to dy du times du dx. Now, I can let whatever's in the bracket,
Yeah,
3x squared plus 5x equals
No,
to
yeah,
u.
but it's doing the whole.
So therefore, I can find du dx, can't I?
Yeah.
So du dx
Wait,
is
it's
6x plus
x.
5. Alright? And then
Wait, it's not
It's just-
integration. It's diffing.
Yeah.
y equals
You
log
can't even use
u. So therefore, dy
Use
du
6x plus
equals 1 over
5
u.
3x squared. plus
Alright?
5x.
So let's put everything together. dy dx is therefore dy du, which is 1 over u,
You can do this
times
all
du
in one
dx,
step.
which is 6x plus 5.
Just do this.
And therefore, dy dx equals to 6x plus 5 over 3x squared plus 5x. Now, the focus question for you now is, what is the relationship between the numerator and denominator? Can you see it?
That's f dash x over f of x.
Yes. So the numerator is actually f dash x, correct? So it's the first derivative of the denominator. Now, in your formula sheet, in your year 12 formula sheet, you have, I've written that, okay? So if fx is 3x squared plus 5x, then dy dx is actually f dash x over fx. Now, this is going to be in your formula sheet. You don't have to write it down. d dx of log of fx is f dash x over fx. It's in your formula sheet. Alright, can you then differentiate these two? And think about what you would do with this. Second one, what would you do? So first one, you can use your formula straight away, which is f dash x over fx. Right? So therefore, the first one, dy dx, would be 2x over x squared plus 5. Now, how would you do this?
Expand.
Expand it. Yep, I would expand it. Makes life a little bit simpler for yourself. Expand it. I mean, if you want to use
Product rule.
what product rule to do it, you can,
Yeah,
but
you can do product.
it might be easier for you to actually expand it. If you've got something like this, you can expand it easier, and you straight away you can see that first derivative of the function in there is 2x plus 7, and then you can straight away get dy dx. All right?
Or you can split them as well.
Sorry.
You can do ln of x plus 3 plus ln
Yeah,
of x.
you can do that as well. You can do the ln over x, ln of x plus 3 plus ln over x plus 4. But then you've got to bring it back, combine it. That's all. So
No,
All right.
It's still the grade.
try 5, please.
Oh, you're gonna have to do it my way now. So
So in this case, you need to know your chain rule, and you also need to know your quotient rule. Incorporating that into your whatever you call it, your product,
Don't need
and quotient incorporating it into your quotient, your chain rule. So therefore, the first one, you could even write it this way. If you want to use it, if you don't want to avoid using your chain rule, use your log rule first.
Oh yeah.
And sometimes it is a little bit easier to use the log rule first, instead of using a chain rule, instead of using a product on a quotient rule. Alright? You could do that if you want to, which means you've got to differentiate in that. Right? But if you use it that way, you can see that this is 1 over x plus 2 over 8 over 2x minus 5. Alright? Think about the second one. How would you do it?
Oh,
Log of that, 2 log of x minus 1 over, take away log of 3x, correct? Yeah? Split it into use your log laws to make it a little bit simpler. You could use your quotient rule if you want to, like I say, but don't make life difficult for yourself. Make life a little bit easier for yourself by using the log laws. 2 log of x minus 1, take away log of 3x, and then you can do your dy dx. Your dy dx will therefore be 2 over x minus 1 and 3 over x, that's all. Alright? I mean, if you use your quotient rule for that, you will come up with something which is slightly different, because you will have 9x squared and so on and so forth. But doing it this way might be more straightforward. Alright? You don't have to actually use a quotient law. Just split using your log laws. Alright, let's move on. Okay, now try this. What would you do with tangent to x?
cosec.
What? Cosec?
No, cosec squared. Oh, no, it's just sec squared. Oof.
Now, you're not doing spec, so you need to split that into sine and cos. All right, spec you could do that, but I would suggest that in this case you split your tangent. Make sure that it's sine. You know that sine 2x over cos 2x. All right. Once you've done that again, log laws.
Oh yeah, fair enough.
Yeah. Make it a little bit easier for yourself. In methods, you're not required to know 10x. All right, but dy dx of 10x, except in this form.
It's gonna go me around.
And therefore, you know that is this case dy dx.
Yeah, okay.
And playing around with it, just rearranging it. I've got 2 over 10 to x plus 2 10 to x. All right, try the next one. What am I? Did I have it incorrectly? That one? That the square should be there. Sorry, my fault. The square should be there. Ah, sorry, it's totally my fault.
He's fully done it.
I love my own typing. So the 2 should be this cos square. All right. So the whole thing is
Yeah.
nah, that should be. Hang on, it's not right either. I've done it like I've typed it incorrectly. Look at this, please. Look at this. So ignore the top width.
You know the derivative of
Yeah.
cos
Ignore the
square
top width.
x.
Just look at this.
It's negative sine.
Yeah.
It's negative
Look
sine
at this.
2x.
Look at my correct. The one that I've written up
Cos
correctly.
squared x.
So that's the
Yeah,
case.
close still.
So therefore,
No,
you need to
x
use your
2 sine x cos x is.
you need to use your product rule.
What do you do with this
You need to use your product rule.
one? 2, so tan 2x is just sine 2x over cos 2x. So you put on the bottom, it's just cos 2x over sine 2x. Oh, you're asking how to do it?
No, put 2 over sine x over 2 cos x.
Yeah, because like remember when you're dividing it, you like bring that denominator to the top and you leave the sign there.
So he went from that. He went from 2 cos x, 2 cos 2x over sine 2x.
Yeah.
To 2 over sine x.
Yeah, you can do that because that's then equal statements. Because like
Yeah.
you bring the cos 2x up and you leave the sign there.
Yeah, it is correct. It's
Yeah,
the same. It's the same convention as cos. So that means
It's very important
the
actually.
whole thing square. All right.
Could
That's the
actually
same as cos
need
square or
to do
sine
one
square. The same convention. That's correct. All right. I've typed it correctly. Correct.
Like yes, like I want to read like this.
All right. So you know to use your product rule. Once you know your product rule, you can actually work that out, and you can simplify it if you want to. All right. You can simplify it. You should actually really, yeah. I would simplify it in that sense.
Wait, so is he doing it with the square at the top?
Yeah.
The square on top is the same as cos square x, sine square x, so the whole thing is square.
Oh, okay.
Same convention. Yeah. I'm more used to this convention. This is the example I took from somewhere else. It's just a convention, that's all. All right, now, what if we need to differentiate y equals to log a of x? As long as a is not 1 and a is not e, how do I do that? So you need to use the change of base. Remember the change of base, change it to natural log first by using the change of base theorem. So that should be in your, whatever you call it, that should be in your formula sheet, I think.
I don't think it's in the.
It's not.
I don't think it is in there.
No, it's not.
So you checked yesterday, I'm pretty sure.
No, I checked yesterday. No, it's not. The change of base is not. So you need to know this. The change of base is not in the formula sheet. So make sure that you know the change of base. So if you want to change your base, log x over log a. I proved it to you a few lessons ago, so I'm not going to go through it again. Now, so if you want to differentiate with respect to x in this case, you need to change that to natural log. Yeah? So if you change it to natural log, you therefore know that 1 over log 6 is actually a constant. Once you know it's a constant, you could take it out. You don't actually have to differentiate that, do you? Yeah? 1 over log 6. So, therefore dy dx is
Factual
1 over log 6
nation.
times 1 over x. Therefore, it's 1 over x
pies,
log.
sausage rolls,
6.
man.
Alright?
Boy, they just are. I'm telling
Now, the next one.
Bro, single boxes.
you. Oh, is it?
What can you do with this? How are you going to work on this?
No, not Pepsi.
Pepsi Max.
I don't drink soft
Alright?
drinks.
Oh, sorry. I forgot.
Pepsi Max
You,
is like-
this is something that perhaps it makes life a little bit easier for you. d dx of log a of x equals to 1 over x log natural log of a. That's it. Alright? That might make life a little bit easier for you if you know that. But you should be able to derive from there to there. Alright, so what are you going to do with this? Change it to ln.
It's quotient, bro.
So, when I change it to ln, what else? Write it as use the log laws.
Just use quotient.
Instead of thinking about all this, if you use the log law, you know that there's ln 5, this is 4 ln x, and this is 2x ln e. Ln e is 1, so you have got 2x left.
Oh.
Alright? So 1
Should've done that.
ln 3 is just a constant. Natural log of 3 is a constant. Correct? So, therefore, you can take that one out, and let's differentiate that. Do I need to differentiate log of 5?
No.
It's a constant. I can differentiate 2x as 2. and you can differentiate that as 4 over x. Right? So make life a little bit easier for yourself. It's 1 over log 3, natural log of 3, into 2 plus 4 over x when you differentiate that bit. And, oops. That's
No
it.
answer.
Alright?
So would you make it like the next step after that would be 2x plus 4 on ln of 3 of x, or times x?
If you want to, but this is perfectly acceptable answer.
Okay.
Alright, this is a perfectly acceptable answer. Not an issue if you don't have 2x plus 4 over x, and then, yeah, that's fine.
Yep. Could I go to the bathroom?
Alright, I'm going to stop here.